In addition to lines of symmetry, today we also want to talk about points of symmetry. Sometimes objects can not only be reflected to show symmetry, but can be rotated about a point to show symmetry. And that type of symmetry is called rotational symmetry. To test to see if an object has rotational symmetry, find the center point of the object. That is potentially what they call the center of symmetry. If this thing does actually have rotational symmetry, then its center point there will be the center of symmetry. Then you'd want to start rotating the object about that center point. Imagine that center point being the middle of a wheel and the object being the wheel spinning around it. Does the rotated object get back to looking like the original object at any point before you get back to 360 degrees of rotation? Of course, everything has rotational symmetry if you spin it one full circle. The question is, does the object you're rotating have symmetry before it gets back to that one full revolution? If so, then yeah, that object has rotational symmetry. If not, then no, the object does not have rotational symmetry. Let's take a look at someone using this very image to do just that.
So let me rotate it and see what happens. So I rotate this around, we reach this point right here, where something magical kind of happens, right? It sort of looks exactly like it was from in the start. And I do the same thing again, and it happens again. And again it happens, and again, another time, and then finally we're back to the start. So what we saw there was that this image, as we rotated it around, it coincided with itself several times. So basically, if that's a fancy way of saying is we rotated it around, and it looked exactly like it did when we started.
So let's talk definitions. First of all, a figure has rotational symmetry if the figure can be mapped back onto itself by being rotated about its center point for less than one full revolution, for less than 360 degrees. The center of symmetry of an object is simply the center of any object that has rotational symmetry. If an object doesn't have rotational symmetry, there won't be a center of symmetry. The order of an object with rotational symmetry is simply the number of times that the rotated object gets mapped back onto the original object during a revolution, during a 360-degree rotation. On the example we just saw, the order for that object would have been 6, because 6 times during the process of rotating it 360 degrees, the original image lined up with the rotated image. And then the magnitude of an object that has rotational symmetry is the number of degrees that it takes to rotate the object until it gets mapped back onto itself for the first time. So keeping in mind there's 360 degrees in a circle, the way you can calculate the magnitude is just taking that 360 degrees in a total revolution and dividing it by the number of times that the object lines up with its original image. Let's look at another part of the video that we were watching before to see these definitions in practice.
We got 1, 2, 3, 4, 5, and then we're back to the start, 6. So my order of rotation simply is equal to 6. But hopefully you'll be able to visualize in your mind on how to rotate this object. So just visualize that you're actually taking it and turning it, and if need be, use some tracing paper if you have to. Angle of rotation, 360 degrees divided by 6. So if we do that calculation, my angle of rotation is 60. We rotate it from here to here, we see that the angle of rotation is simply how long does it take for the object to coincide with itself, or how much of a rotation does it take for the object to coincide with itself. So we see that this object, from here to here, to rotate it, it's 60 degrees.